All right, today we are opening a cosmic cold case file. We're talking about a detective story set 13,000 light years from Earth. And it's got everything: stellar cannibalism, record-breaking physics, and a mystery that really makes us question what we know about the universe's most extreme places. And our story? Well, it starts in the oldest, most violent cities in the cosmos.
I know, it sounds like something straight out of a horror movie, but it's a reality inside what we call globular clusters. And for our investigation, these are the crime scenes. So try to picture a city, but not one with people, one made of stars.
Globular clusters are unbelievably old, some of the first structures that ever formed in the universe. But their defining feature? Pure density. I mean, they are packed so tight with stars, they basically become stellar demolition derbies. This proximity forces stars to interact in ways that just don't happen out here, in the quiet suburbs of our galaxy.
So, what happens when you cram that many stars into one place? Well, things get chaotic, but also incredibly creative. It's how some of the most bizarre and exotic objects in the entire cosmos are born.
Think of it like a ridiculously crowded dance floor. Stars are so close they can literally grab each other, forming new binary pairs, or even steal partners from other systems. This constant shuffling makes globular clusters about 1,000 times more efficient at creating exotic binary stars than the rest of the galaxy. And these interactions, they are the absolute key to finding the very things we're hunting for.
So, our crime scene is set. Now, every good detective story needs the detectives, a high-tech tool, and of course, a very specific kind of clue to search for. The crucial piece of evidence in our case is the millisecond pulsar. Now, this is not your average star. Far from it. It's basically the corpse of a massive star, a super dense neutron star that's been, well, recycled. It's been brought back to life, in a way, by feeding on its companion. So how do you recycle a star? Here's the recipe. First, you need a dead neutron star that's in a binary system with another star. Then it starts siphoning off gas from its partner. As that material spirals down onto the neutron star, it transfers momentum, spinning it up to unbelievable speeds. We're talking hundreds of times a second, faster than a kitchen blender. And just like that, a millisecond pulsar is born. And our detective's main tool? It's this magnificent instrument, the 500-meter aperture spherical radio telescope, or FAST for short. For 7 years, astronomers used FAST to conduct a deep search, a cosmic census really, of 41 globular clusters, just listening for the faint, rhythmic ticking of these recycled stars.
Okay, so we have our tool, and we know what we're looking for. Now let's turn our attention to one very specific neighborhood, a pretty unassuming cluster known as Messier 71.
Now, this map shows how astronomers predict where to look for pulsars. They calculate something called the stellar encounter rate, which they call gamma. A high gamma, which you see in the red and pink dots, means more stars bumping into each other, and that means a better chance of finding pulsars. So logically, that's where you'd focus the search, right? But that's not what happened. The really shocking discoveries, the biggest surprises, didn't come from the hotspots. They came from Messier 71, a quiet, low-density cluster. See it there? The humble blue diamond on the map? It wasn't supposed to be special, but it was hiding some of the most extreme star systems we've ever found. And that is the central mystery of our case. The clues they found in Messier 71 belong to a really bizarre class of objects. They're known as spider pulsars. And they got that name because, well, they have a nasty habit of devouring their companions. And there are two main types of these cosmic arachnids. You've got your black widows, where the pulsar's intense energy is literally blasting its tiny companion star to bits. Then you have the redbacks, which are feeding on a slightly larger companion. And these are exactly the unusual suspects they found lurking in Messier 71. So, let's meet our first key suspect, M71A. Its official designation is PSR J1953+1846A. This is a classic black widow. After astronomers pinpointed its radio signal, they used the Hubble Space Telescope to zoom in and find its companion, just a tiny, faint star that gets brighter and dimmer as it's being blasted by the pulsar's wind. It was definitive proof of a destructive spider system.
But then they found M71E. And the most shocking thing about it wasn't what it was doing, but how fast it was doing it. 53.3 minutes. Let that sink in for a second. That is its orbital period. For comparison, our moon takes nearly a month to orbit Earth. This star whips around its partner in less time than it takes to watch a TV show. It is by far the shortest orbital period ever found for a spider pulsar system.
And the true significance of this find is just how strange it is. That little smudge you see is the companion star, captured by Hubble. Its unbelievably tight orbit suggests it's a cosmic missing link, a system caught in the very act of evolving from a bigger redback system into a smaller, almost completely devoured black widow.
Now, finding these bizarre cosmic spiders is thrilling all on its own, for sure. But these discoveries actually have profound implications for the very foundations of physics itself.
Which is a fair question, right? Why spend years pointing a giant telescope at the sky, hunting for these faint, distant signals? What's the real payoff here?
Well, the answer is that these pulsars are perfect natural laboratories. Their pulses are so incredibly precise, they're like cosmic clocks. And with them, we can test Einstein's theory of general relativity in gravitational fields so strong we could never, ever hope to create them here on Earth. They let us probe the basic laws of physics and even search for the subtle effects of dark matter.
And this brings us right back to Messier 71. See, it's not just about the destructive spiders. They also found another pulsar there, M71B, which is in a very long, stable orbit. This makes it the perfect tool to test something called the strong equivalence principle, a key piece of general relativity. The main point is, this one quiet cluster has given us an entire toolkit for testing the limits of physics.
Which leaves us with one final, tantalizing thought. The strange case of Messier 71 proved that our predictions about the universe can be spectacularly wrong. It showed us that even the most seemingly unremarkable, quiet corners of the cosmos can hide the most extreme objects we know of. So it just makes you wonder, if a place like M71 holds secrets like these, what else is hiding out there in the dark?